Welcome to Demystifying Math. In this lesson, we're going to be graphing Rose curves. Let's start off with a Rose curve represented by r equals a cosine n theta. These are going to graph Rose curves as long as your n value is greater than or equal to 2. You will have n petals if n is odd, and twice as many petals as n if n is even. The distance from the pole to the tip of a petal is the length of a, which is the coefficient of the cosine. We can do a test for polar axis symmetry by replacing theta with negative theta. Since the cosine of the negative of an angle is equal to the cosine of the positive of the angle, you have polar axis symmetry. Let's take a look at the same graph but using the sine function. We have r equals a sine n theta. Again, if n is greater than or equal to 2, you will have n representing the number of petals if n is odd. If n is even, you'll have twice as many petals as n. The distance from the pole to a tip of petal is still a. In this case, we're going to test for symmetry by replacing theta with negative theta. But in order to get it to equal a sine n theta, we have to take the opposite of the sign. So that means that we have symmetry with respect to the line theta equal pi over 2. Let's go back over this again. Okay, so here we have a cosine graph given by a cosine n theta. At this point, a is 4 and n is 2. What we want to do is change our value of n and see what happens to our graph. Notice that right now n is 2 and we have 4 petals. Now n is 3 and we have 3 petals. Now n is 4 and we have 8 petals. Notice that when we have an even number of petals, if we have an even number for n, we have twice as many petals as n. And when we have n being odd, we have the same number of petals as n. So right now n is 5 and we have 5 petals. Here n is 6 and we have 12 petals. I also want you to notice the symmetry of the graph. So this is a cosine graph, and notice that for every one of these Rose curves, we have a point on the polar axis at the angle of 0. So that's going to make it easy for us later on to figure out where our petal tips are. Okay, now let's change our graph a little bit, and we're going to make this into the sine graph. Now notice with the sine graph, if I have n is 2, I have 4 petals, n is 3, I have 3 petals, n is 4, I have 8 petals. So it's still working the same way that it did with the cosine graph. If n is odd, you have the same number of petals as n. If n is even, you have twice as many petals as n. Now let's go back and look at the symmetry of the graph. Now with this graph here, you can see that you have symmetry with respect to the line theta equal pi over 2, or the vertical axis. And that's true for all the graphs. Now notice that with the even graphs, you have more symmetry than you do with the odd graphs, but at least you can say that all of them have symmetry with respect to the line theta equal pi over 2. Okay, so let's draw a specific graph. We have r equals 5 sine 4 theta. In this case, n is even, so there are twice as many petals as n, or in this case, there's 8 petals. Your a value is 5, so each petal has a length of 5. The sign is used so the graph is symmetry with respect to the vertical axis. And what we want to do is figure out where our petal tips are. And we're going to do that by comparing our graph to the rectangular form and finding the critical points. So looking at the rectangular form of y equals 5 sine 4x, you can find the period of the graph by dividing 2 pi by 4, which in this case simplifies down to pi over 2. So within pi over 2 units, we're going to have 4 critical points. So remember, that's going to create one entire period. So you should have a 0, a high, a 0, a low, and another 0 within pi over 2 units. And each one of those critical points, a high, a low, or a 0, is evenly spaced over over pi over 2 units. So we're going to take our pi over 2 and divide it by 4, or multiply it by a fourth. And that's going to tell us how often we have one of those critical points. So if you take 2 pi over n, which we use to find our period, and multiply it by 1/4, you're going to get pi over 2n. So pi over 2, which was our period, times 1/4 gives us pi over 8. So every pi over 8 units, we're going to have a critical point, either a 0 or a high or a low. Okay, so what we want to do is list out all our critical points. 0, pi over 8, 2 pi over 8. So here's pi over 8. 2 pi over 8 is the same as pi over 4. 3 pi over 8. Then we have 4 pi over 8, which is the same as pi over 2. Then if we wanted to, we could go another period and keep going. Now notice that every other one of those critical points is a 0. So those would be at 0, pi over 4, pi over 2, and so on in lowest terms. And the other ones are going to be highs or lows. Now on this graph where we have a high point or a low point, that's going to give us our petal tips. Some of these are going to give us negative R values when we compare it to the polar equation, and some are going to give us positive R values. But we can find out where these petal tips are pretty easily. So let's go ahead and do that. If you take pi over 2n, which is how we found our critical points, and say, well, every other one is going to give us a petal tip, so we're just going to multiply that by 2 and we get pi over n. So your highs and lows are going to occur every pi over n units, which means for this particular graph, it's pi over 4 units. The first petal tip is going to start at 0 for the cosine graphs, which we saw on the sketch a little while ago, and at pi over 2n for the sine rose curves. So in this case we have a sine graph, so it's going to be at pi over 2n is our first one, so that's our starting point. And then what we want to do is add our pi over n, or in this case pi over 4, to that angle and find our next angle. So I did that here. I kept adding pi over 4 until I got, in this case, 8 angles, because I have 8 petals and 8 petal tips. Now notice that when I went to graph some of these, I have those negative R values, and actually every other one is going to be a negative R value. So we started off with pi over 8, that's going to be at 5, and then when you plug 3 pi over 8 into your equation, you get out a negative 5. So that's going to give you this point over here in quadrant 3. Then at 5 pi over 8, I have a positive 5. And at 7 pi over 8, I ended up with a negative 5. So you can start to see how the graph works. Okay, let's look at another one. We have 5 sine 3 theta where n is odd, so there are 3 petals. A is 5, so each petal has a length of 5. And we can find the tip of the first petal by dividing pi by 2n. So that's going to give us pi over 6 as our starting point. Then your petal tips occur at intervals of pi over n, which in this case is going to be pi over 3. So we're going to take pi over 6 and add pi over 3 to it until we get 3 petal tips. And remember that you're going to have alternating positives and negatives, so you can easily find out where your petal tips are. The next one is 5 cosine 4 theta. N is even, so there are 8 petal tips. A is still 5, so that's the length of our petals. And this is a cosine graph, so your first petal tip is going to be on the polar axis at 0. And then we need to figure out where the next petal tip will occur. So we're just going to continually add pi over 4 to the previous petal tip until we get, in this case, 8 petals. Now remember, these are alternating positive and negative R values, so look and see where you need to plot them. Our next one is 5 cosine 3 theta, and is odd, so there are 3 petals. A is still 5, and this is a cosine graph, so we're going to have a petal tip on the polar axis at 0. Our petal tips are going to be occurring every pi over 3 units, so we're going to add pi over 3 to our starting point. We have 0, pi over 3, and 2 pi over 3 for our petal tips. Okay, thank you for tuning in to Demystifying Math.